This video we're going to look at inequalities, in particular linear, quadratic, combining inequalities together and set notation. It's not particularly difficult. These are slight extensions to things you might have seen at GCSE, but there are a lot of places where you can make silly mistakes. And so I'm going to be talking about how you can overcome them. One of the most common mistakes is with quadratic inequalities, where students don't draw a graph. And then they get the questions wrong and lose a lot of marks. So, with the quadratic inequalities, you're going to hear me say this a lot, you must draw the graph. Anyway, let's have a look at the linear inequalities first. This question asks us to find the set of values of x for which 12 minus 2x is less than or equal to x plus 27. You can see on the left-hand side, we've got a worked answer there. This person has subtracted 12 from both sides first. Then we can see that they have subtracted x from both sides. And then to go from this stage to this stage, they've divided by minus 3. And they have correctly swapped the inequality around. So they've got the answer as x is greater than or equal to minus 5. That's one common mistake with inequalities. If you multiply or divide by a negative number, you must flip the inequality sign around. Me personally, I prefer to rearrange slightly differently to that. If it was me, I would add the 2x to both sides first. Then I would subtract the 27. And that way I can divide by positive 3 without needing to worry about flipping the sign or anything like that. And I get the correct answer as x is greater than or equal to minus 5. We can represent that answer on a number line where I would draw a circle at minus 5. I'm going to colour that circle in because we can include, and we need to include, the minus 5 here because of the line underneath. And it's going to be any number greater than minus 5, so that's all of the numbers up there. We could give our answer in set notation. Now, in set notation, you have these curly brackets. These curly brackets are going to represent all of the numbers inside them. So it's a set of numbers. Now, when we do set notation, the first part of the bracket, that's going to be the variable that we're talking about. In this case, it's x we're talking about. These dots means such that. So over here, we're then going to have the condition that x needs to obey, which in this case is that x has to be greater than or equal to minus 5. So we are saying that we've got the set of values of x such that x is greater than or equal to minus 5. So just a quick reminder, always curly brackets like that. Always a colon in the middle, which means such that. This is the variable we're talking about, and this is the condition that that variable has to obey. Right, quadratic inequalities. So a couple of examples we're going to do, and again, you can see I've said you've got to draw the graph. You've got to draw the graph. Really important. And I'll show why that's important. So, we've got the quadratic inequality x squared minus 4x minus 12 is greater than 0. I'm going to factorise this to begin with. Like that. And now I can see from that I've got the root of 6 and a root of minus 2. Now, a real common mistake that students make is they just go, oh, x is x, and then they just copy this sign randomly down. That is completely wrong. Instead, what we're going to do is draw a sketch of this quadratic it had a root at 6 and a root at -2. So the quadratic looks roughly like this. You can see it's not a perfect sketch. We don't need to work out the turning point or the y-intercept or anything like that. But now I can use that graph to find the values where the graph is bigger than 0. It's bigger than 0 all the way over here and all the way over here. This part of the graph is where x is bigger than 6. And this part of the graph is where x is less than -2. So you can see when I wrote it down the wrong way earlier, I wrote -2 here, and then I just randomly copied this down and said x is greater than -2. That is wrong. So you can't just factorize and just put the inequality in random places. You have to draw the sketch. Now, representing that in set notation, I can say the set of values, so my curly brackets. In fact, actually, let me draw it a little bit smaller. So this is the set of values of x such that x is less than -2. So this is the set of numbers over here. Or it could be the set of numbers of x such that x is greater than 6. So this represents all the numbers over here. And it could be in either of them. It could be in this set or this set. The symbol for or, which you may remember from Venn diagrams in GCSE, is like a big U. So this is the set of values of x where x is less than -2, or the set of values of x such that x is greater than 6. Second quadratic inequality, we've got 2x squared plus 5x is less than 3. I'm going to take 3 away from both sides. So my inequality will be less than 0. I'm going to factorize this so I can work out the roots to help me to sketch it. So I'm going to need to have a +3 and a -1. Just double check that. The 2x times the x is the 2x squared. The 1 times the -1 times the 3 is -3. And then crucially, the 2x times the 3 is 6x. The -1 times the x is -x. And the 6x and the -x do give me the 5x. Draw a sketch. So I've got the root of 1/2 from here. And then I've got a root of -3 from there. So 1/2 and -3. Here's -3. 1/2 is roughly there, put in the right place this time. So my quadratic will look something like this. I'm looking for my quadratic to be less than 0 this time, which is where my graph is below the x-axis, where all the y coordinates down here are all negative, which is where the x is greater than the -3, but less than the 1/2. Writing that in set notation, I can say the set of values of x such that x is greater than -3 and less than 1/2. Notice that this can be written as one set of values because there is one region here. Whereas over here we had to have two sets of values because there were two regions. Right, combining inequalities. So this question here says that we need to find the set of values of x for which 3x minus 1 is greater than or equal to 5 and x squared minus 8x plus 15 is greater than 0. You can see I've solved the linear inequality to find that x is greater than or equal to 2. And I've started the process of the quadratic by factorising to find the roots of 3 and 5. So I can draw my quadratic sketch in now. And we're looking for the values where it is greater than 0, which is the values down here where x is less than 3 or greater than 5. Now, both of these things need to be true. We know from here that x has to be greater than or equal to 2, and we know from here that x is less than 3 or greater than 5. Now, a common mistake that students make here is they just look at the 2 here and say, right, well, x has got to be bigger than 2, and x has got to be less than 3. And so they'll write down something like that. But that is not completely correct. So let me show you a way that we can be absolutely sure to get this right. And we're going to just quickly draw a number line. So go ruler. So my number line 0, 1, 2. That should be enough. Right. In green, I'm going to put this number line on, this inequality. So we're saying that x has to be greater than or equal to 2. So here's 2, here's equal to 2. These are all the values where x is greater than 2. And now in yellow, I'll put this inequality on, which is saying that x has to be less than 3. So just above, I'm going to do this. X is less than 3, which is all of those values, or greater than 5, which is all of those values. Now, where is there a green line and a yellow line? Well, there's a green line and a yellow line in between the 2 and the 3. So that is the answer that we had before. But there is also a green and a yellow line where x is greater than 5, which was the part of the answer that was missing before. So if you make sure you draw a number line, you will not forget any part of the answer, and that can avoid that mistake. Last thing to be careful about with inequalities for this video is where we have something like this, where we've got 6 over x is less than 2. Now, the problem that students often have with that is they look at it and their instant reaction is to multiply both sides by x. And so they will write down something like 6 is less than 2x. But there is a big problem with what I've just done. I've just multiplied both sides by x, and I don't know what x is. If x is positive, what I've written down there is correct. But if x is negative, I should have had to have flipped the sign. Because if I'm multiplying both sides of an inequality by a negative, I have to flip the sign. So I don't know whether it should be like that or whether it should be like that. Without knowing what x is, I can't know. But there is a trick we can do. Instead of multiplying both sides by x, I'm going to multiply both sides by x squared. Because by doing that, I know that x squared is always positive. Therefore, I know by multiplying both sides by x squared, I don't need to flip the sign. It is definitely a positive number, so I can keep the inequality the right way round, the way it's written. On the left-hand side then, I've got x squared times 6 over x. All these would cancel out and I would just get 6x. On the right-hand side, I've got 2x squared. I'm now going to divide both sides by 2 to make these numbers a little bit smaller and easier. This is a quadratic, so I'm going to subtract 3x from both sides. I'm then going to factorise to find the roots. Draw a sketch, draw a sketch, draw a sketch for a quadratic inequality. I've got a root of 0 from here, and I've got a root of 3 from here. So my quadratic inequality will look like this, and we're looking for where this is greater than 0, which is here and here. So it is where x is less than 0 or greater than 3. So quite a few things there to be careful about in this topic. Remember, if you're multiplying or dividing both sides of an inequality by a negative, you need to flip the direction. If you are solving a quadratic inequality, you have to draw a sketch. If you are combining inequalities together, draw a number line. And if you're multiplying both sides of an inequality by x, do x squared instead, because that way you know it's positive.